All right, everybody. Let me just go back to here. Yes. So, hello, everyone, and welcome back to another video. In this lesson, we're going to talk about a special type of function that is called natural exponential function. Basically, we can say that natural exponential function is a special type of exponential function. Why it's special? Like during the lesson, during the explanation, you will find out like what is special regarding to natural exponential function. Well, natural exponential function is a function that its base is always fixed. Like there is something specific in the base of the our exponential function. Remember in the previous lesson we discussed about exponential function a lot, decay, growth, and like the conditions to become like decay, and as well as for being growth, what kind of base we need. We discuss about all these kind of stuff, and today we're going to talk about natural exponential function and its graph, and how are we going to graph it. Of course, we have got two ways: the the table value method, and of course the transformation, that it is going to make everything easier. So let's just go to the main slides. This is the definition of natural exponential function. It says the function f of x equals to e powered by x. So in the beginning I said it's a special type of exponential function. Why it is special? Because the base is fixed and it always like equals to something specific, which is e. So what about e? What is e? Okay, what is e? Remember, e equals to 2.71. So approximately we can say that our e equals to 2.71. So it's approximately, not exactly. So from now on, consider e as 2.71. Since e is a number greater than 1, so the parent function would be a growth exponential function. Imagine here is the coordinate plane. So the graph of e powered by x, since e is greater than 1, it's going to become a growth exponential function. All right? And of course, this one is 0 and 1, because the growth and decay exponential function, the parent function, always goes through 0, 1. Take care of this point. Perfect. And what else about like natural exponential function? Since it is an exponential function, we already defined its domain and range, and we said that domain is all the real numbers. Why? Because x can take any number, all right? Like positive, negative, 0, fraction, decimal, anything. And how about the range? So range is the one which is going to change. So it depends on the type of function, the type of the function. So sometimes we have got a number next to this x. Sometimes we have got another term that is added or subtracted to e powered by x. Sometimes there is a negative behind e powered by x. So in each case, the range is going to change. But based on the parent function, as you can see, this graph is almost like from 0. This side, when x tends to the negative infinity, the graph like comes like closer and closer to x-axis, which is 0, but it's not gonna like touch the 0. That's why we are gonna say that, okay, the range is from 0, open interval. Open interval will tell us that it's not gonna include 0, and it goes up until positive infinity. That is regarding to the range of natural exponential function. All right. So remember, e equals to 2.71 approximately. Otherwise, there are like infinite digits. So next, we have got some properties of natural exponential function, which we already are familiar with them, because in section of powers, since like 6th grade, we actually study them. Let's just review them, but this time when we have exponential function, so the story is about it. All right, e powered by x multiplied by e powered by y. We already studied if we multiply powers of the same base, all right, we chip the base and add the exponent. Imagine, let me just give you some examples when we are just explaining them. Okay, red. E powered by x multiplied by e powered by y. So e powered by 2 multiplied, let's say, by e powered by 6. So it's equal to e powered by 8. Why? Because in multiplication of powers with the same base, we are going to just add the exponents. All right. How about in division? Well, in division, we are going to subtract them. Simply, let's say e powered by 10 divided by e powered by 7. We are going to say that e powered by, if you subtract 7 from 10, we're going to get 10 minus 7, which is 3. All right, the next one, if we have two exponents together and one bracket between them, again, we are going to chip the base. Always in each case, chip the base and never change it. So chip the base. Let's imagine we have got e powered by 2 powered by 8. So in that case, chip e and multiply the exponent. So 2 times 8, it's equal to 60. All right. And there is a famous case that everybody is familiar with it. So we are going to say that any number powered by 0 equals to 1. So no matter what is the number, except for one case, which is 0 itself. So 0 powered by 0 is undefined. But any other number powered by 0 equals to 1. How about the last case? We have got negative exponents. So for negative exponents, we are just going to take the reciprocal form of it. Or, in another words, we are going to just flip the term. So let's imagine we have got e powered by negative 6. So e powered by negative 6. In that case, since the exponent is negative, we need to flip it in order to make that negative exponent to positive. All right, in that case, we are going to say that it's equal to 1 over e powered by positive 6. That's all about the properties of natural exponential function. So let's get to the main point, which is graphing the natural exponential function. As I already said that, mentioned it, that we have got two ways, either to graph the natural exponential function, either table of value method or following the transformation method. So for table value, it's very easy. We already tried it when we were dealing with decay and growth exponential function. We will do it here again. So table of value method, graph the function f of x equals to e powered by x minus 1, then find the domain and range. So we have got two responsibility to do. Like, first of all, we need to fill this table and get the value of y's when the x's are given. You are familiar already with this 5x. We need to substitute each one of them into this function instead of x, replace it, and get the value for each one of them. All right? What I mean by get the value of y. And then we will graph it. Then at the end, we will discuss about its domain and range, of course. So here, e powered by 0, it's equal to 1. Number powered by 0 equals to 1. 1 minus 1, 0. So e powered by 0 minus 1. E powered by 0, it's 1. 1 minus 1, of course, it's equal to 0. So 0, 0. E powered by 1, it's equal to e itself. What was e? E powered by 1 minus 1. E powered by 1 is 2.71. Minus 1, it's equal to 1.71 approximately. How about 2? E powered by 2. E powered by 2 minus 1. E powered by 2, if you just go and calculate, use a calculator to calculate this, it's going to give you 7.38 almost. Minus 1, it's equal to 6.38. From the negative side, e powered by negative 1, e powered by negative 1 minus 1. So e powered by negative 1, I just replaced negative 1 into the x. So e powered by negative 1, it's equal to 0.36 minus 1. If I'm not mistaken, it's equal to negative 0.64. So negative 0.64, let's say, or 6. How about e powered by e powered by negative 2 minus 1. So e powered by negative 2 is equal to 0.13 minus 1. Approximately it's equal to 0. Negative. Negative 1 is bigger than 0.13 and its sign is negative. So the result would be with negative. Negative 0.87, let's say. So negative 0.87. Right now we are going to just plot this point on a coordinate plane. Imagine our coordinate plane is over here. Let's just imagine it. All right. 0 and 0. So 0 and 0 is here. 1 and 1.71. Let's say 1.71 is here. Okay. And let's imagine 1 is over there. So the point would be exactly over there. 2 and 6.38. Let's imagine 6.38 is over there. So 2 is here. They're just going to intersect each other here. And from the negative side, we have, let's say negative 1 is here and negative 2 is over there. So for negative 1, we have got negative 0.64. Let's imagine here is negative 0.64. So the points are gonna is going to be over there. And then finally for negative 2 we have negative 0.87, which is lower than negative 0.64. Be careful. So the point is going to be over there. So if you just want to graph it, the graph would be something like this. At the K1, but it goes through these points that we already got them. All right, this is the graph. And of course, let's imagine here is negative 1. So the negative 1, the graph is above exactly negative 1. Y equals to negative 1. So that is the graph. How are we going to graph it? All right. Domain is all the real number because it's an exponential function. And the range is from negative 1 to positive infinity. Why negative 1? Because as you can see, the graphs like goes and tends to negative 1 on y-axis, but it's not gonna never like change, touch the y equals to negative 1. That's why we are gonna say that it's from negative 1 open interval to positive infinity, because it goes up, and this is the story of graphing this function. Perfect. Let's move to the next question. Let's see what we have here. So we have got another exponential function, but this time e powered by x minus 1. So the number is in the exponent. So let's just deal with it. All right. E powered by, first of all, instead of x, we have got 0 minus 1. So it's equal to e powered by negative 1. E powered by negative 1, it's equal to 0.36. How about e powered by 1 minus 1, which is e powered, instead of x, I put just 1. So 1 minus 1, 0. E powered by 0, it's equal to 1. E powered by 2 minus 1, it's equal to e powered by 1. E powered by 1, it's 2.71. And then e powered by negative 1 minus 1, which is e powered by negative 2. So remember, it was equals to 0.36. And then finally, e powered by negative 2 minus 1. So it's equal to e powered by negative 3. I'm not sure about this one. Let me just bring my calculator. Sorry for this one, in order to make sure and give you an exact result, and to use the calculator. So remember, alpha e powered by negative 3. So it's equal to 0.04. 0.04. Perfect. Right now, let's just graph it. This is our coordinate plane. Let's plot these points. All right. At 0, we have 0.36 as something like lower than 0 and less than 1. Let's imagine here is 0.36. So here is going to be the point. At 1, we have got 1 exactly. So let's say it's here. Here is 1 and here is 1. So the graph is something like this. Let's imagine here is 2. And here we have got 2 points, not over there, it's a little bit higher. So let's imagine here is 2.7. 71. So from the negative side, what do we have? We have got 0. For negative 1, 0. Sorry, negative e powered by negative 2. It's equals to 0.13. Let's just try it. Alpha e powered by negative 2. So it's equal to 0.13. All right, 0.13. Let's imagine it's here. And 0.04, it's definitely lower than 0.13. So let's imagine it's almost here, or negative 2. All right. So right now we are just going to plot these points from here, something like this. This is going to be the graph of it. And from negative infinity, just go on, but never going to touch the x-axis. And this is the graph, by the way. And I really hope that you do understand it, because it's easy. We are just going to substitute the value, the given value, which is the x values. Here is 2.71, into the x, into our function, and get the value of y, and then plot them on a coordinate plane. Then we can discuss about domain and range. Okay, domain is all the real numbers. Range is, look, the graph is above x-axis, which is 0. So from open interval 0 to positive infinity y, because it goes to positive infinity, it goes up. Perfect. Next question, let's see what we have. Since, okay, e powered by x plus 1, then we will go to transformation. But let's just first deal with this one too. Okay. So e powered by x plus 1. Remember, in the first example, we had minus 1. So here we have got plus 1. All right. E powered by 0, it's 1. 1 plus 1, 1 plus 1, it's 2. E powered by 1, it's e. Plus 1, it's 3.71. Why? Because 2.71 plus 1 is equal to 3.71. All right. E powered by 2, it's 7.38. Plus 1, it's 8.38. Approximately. E powered by negative 1, it's equal to 0.36. So plus 1, it's equal to 1.36. E powered by negative 2, it's equal to 0.13. Plus 1, 1.30. Perfect. Now our coordinate plane is over here. Let's plot the points that we have got. At 0, we have got 2. Imagine here is 2. At 1, we have 3.71. Let's imagine here is 3.71. At 1, we have got 3.71. At 2, we have 8.38. So 8.38. Here is it. And at negative 1, we have 1.36. So imagine here is 1. So 1.36, let's just imagine it. It's over there. Negative 1. So here is going to be the place of the point. And negative 2, at negative 2, we have 1.13, which is lower than this point. So let's imagine it's over here. Almost. And then finally, we are just going to connect these points. This is going to be the graph. But I want you to write this y equals to 1. Y equals to that one, and see the graph is exactly above that line. Just y equals to 1. We call that line, later on even I will mention it in transformation, we call that a y equals to 1, or anything else, if it is 2, 2, if it is negative 1, negative 1, whatever it is, it has a special name that in the old book it's supposed to, like, it was written, but in the new one, they just remove it. But in grade 12, again, you will face it. It has a specific name, which is called horizontal asymptote. So that is called horizontal asymptote. Perfect. How about domain and range? Well, for domain, since it's an exponential function, again, we are going to say that it's all the real numbers. How about the range? guys, the range is very important here to get. As you can see, the graph is above y equals to 1. So the lowest y, it's almost 1, but never, like not exactly 1. That's why we put open interval. And goes to positive infinity. It goes up. There is no bound for it. That's why it goes to positive infinity. Perfect. That's regarding to table value method. And I hope that it is clear. There is a table. Some inputs are given, which is x values. And we need to find the y values. Then after that, we are going to plot those points that we have got on coordinate plane. And then connect them. That's going to give us the graph of the exponential function. Then based on the graph, we can decide about the domain and range. Perfect. The next thing, let me just check the camera. Yeah, it works. The next thing that we are going to discuss about it is graphing the natural exponential function, but the second way, which is to transform a parent function exponential, apparent natural exponential function on coordinate plane. We have got three types of transformation. So the first one is horizontal transformation. If we have f of x equals to e powered by x in the exponent, either we have got plus c or minus c. If we have got plus c, there is a plus here, e powered by x plus c, we will transform the graph c units to left. And if you have got e powered by x minus c, if there was negative in the exponent, we need to move to the right side. So let's just summarize it. If we have a natural exponential function and in the exponent, if there was a number like subtracted or added to x, if there was positive, like x plus c, we will move to left. If there was negative, we move to the right side. We will see that. We will see it in during the question. And the second transformation is reflection transformation. If there is a negative behind e powered by x, we will reflect it with respect to the x-axis. If there is a negative in the exponent behind the x, we will reflect it with respect to the y-axis. Vertical transformation is if there is a c, like a different term, subtracted or added to e powered by x. Remember, it's not in the exponent. If it is in the exponent, if the changing number is in the exponent, we go horizontally. But if it is a different term, we need to move vertically. If it was positive, go upward. If it was negative, go downward. This is all about transformation of a natural exponential function in that book that you follow. So let's go through the questions, and I'm pretty sure by solving the question it's going to be more clear. So here let's say graph the function by using transformation method, find the domain and range. So imagine if you have got three graphs over here. Okay, three graphs. So the first one is parent function, and I believe everybody is familiar with it because we already discussed about parent function. So it goes from 0 to 1. And the second one is e powered by x plus 1. Since the changing number is in the exponent and it's positive. Remember we said that if there is positive, we need to go to left. How many units? 1 unit. So imagine here is -1. And here is exactly 1. So the graph would be something like this. Let me just change the color in order to make it more clear. White is better. So in that case, the graph would move here. That is going to be the transformation, which is we call it horizontal transformation. And the last one, we have got e powered by x minus 2. And as you can see, -2 is a different term. It's not in the exponent. So in that case, we said that if we have got positive, we go upward. But if there is a negative, as you can see here, there is a -2. So in that case, we need to move the parent function 2 units down. Based on these points, we are going to decide, which is 0 and 1. So if you just move it 2 units down, This is 1, and if you move like one more, so it's going to come on -1. But remember, always we need to make a line that it is equals to that number next to the e powered by x, which is -2. So imagine right now we have got -2. In that case, let's imagine -2 is here. So the line of y equals to -2 is something like this. Now it's going to tell us that the parent function, which is e powered by x, is above that function, above that line. So in that case, the parent function goes through -1, and it is above -2. So if you want to check it whether your graph is correct or not, as a suggestion, I strongly recommend you to replace 0 with x. So in that case, e powered by 0 minus 2. Everybody know that e powers by 0, it's equal to 1. So 1 minus 2, it's equal to -1. And as you can see, the graph goes through -1. There are some people who are waiting for our smartboard. They need it. That's why they actually interrupt my video. Inshallah, I will finish it. I will complete it. So as soon as possible, I will do the remaining part of this lesson. Just be patient. Everybody, as I already said, that because of some technical issue, they actually interrupt my lesson. But let's just continue from now and from this slide again. I would love to. I guess we did this one, so let's just move to the next slide. We have got like different graphs to different functions to graph. All right, we have got 3 more graphs. Here, graph the function by using transformation method, then find domain and range. Guys, let me just make this transformation clear. If there is a number in the exponent next to the x-axis added or subtracted, we go horizontally. Remember, if the number is in the exponent, we need to transform horizontally. If it is positive, go left, and if it is negative, go right. Then regarding to reflection, there are 2 cases. If there is a negative behind e powered by x, just something like this, we will reflect it with respect to the x-axis, and if there is a negative in the exponent, we are just going to reflect it with respect to the y-axis. Regarding to the vertical transformation, if there is a different term next to e powered by x or negative e powered by x, there is a different term, a consonant term, which is a number, let's say, +1 or -1. If there is plus, we need to go upwards. And if there is negative number, we need to go downward. Let's deal with these 3 functions. All right, we need 3 coordinate plane, 3, and then finally we can transform them. All right, the first one, e powered by x. What do we call this one? This is very famous, and I guess everybody know it. So we call it parent function, and it goes through 0 and 1. So based on that point, we are going to move the graph. The next one is negative e powered by x. We said that if there is a negative behind e powered by x, we are going to reflect it with respect to the x-axis. Which one is x-axis? This one is x-axis, that one is y-axis. So if we just reflect it with respect to x-axis, the graph would come to the would come below the x-axis, something like this. This is going to be the graph of negative e powered by x. All right, this is what we call reflection with respect to the x-axis. All right, something like this. Reflection, imagine x-axis is just like a mirror, okay? When you just stand in front of a mirror, it's going to give you back the image. So imagine x-axis is just a mirror. So here is our object, which is the graph. So the picture would come exactly here, here, and when we graph it, it's going to, so here is e powered by x, and this one is negative e powered by x. The last one, which is very, very important for the exam, and it goes, by the way, through -1, be careful. We need to transform the graph of negative e powered by x 1 unit up. So it means that's negative 1. If we just move it 1 unit up, it's going to come on 0. All right, it goes through 0. And of course, that part of the graph would be under exactly y equals to 1. Again, our horizontal asymptote is equal to y equals to 1. So let's just first draw this line, y equals to 1. And the graph, we know that it goes through 0, 0. Why? Because we said that we need to transform it 1 unit up. Vertical transformation. So from negative 1, the graph would come to 0. So the graph would be something like this. This is the graph of negative e powered by x all plus 1. So right now, domain of this one, domain of the parent function is, domain of all of them is all the real numbers, but the range of the parent function, you know that it's from 0 to positive infinity. Perfect. And the range of this one, which is negative e powered by x, so since it's like goes down, so it goes to negative infinity. So we are going to say that the lowest value of y is negative infinity, and the greatest value is going to be 0. Again, open interval. And here actually is that one. And the last one, domain is all the real numbers again. And the range is from negative infinity to positive 1, because we transform it 1 unit up. So it goes to almost 1, but not exactly 1 itself. Well, I will give you 2 notes in order to not forget about them. Let me just give you 2 notes. Okay. Remember these 2 notes, note 1 and note 2. So note 1 say that f of x equals to e powered by x plus minus b. In that case, domain is all the real number, but range, if here is positive, so from that's b to positive goes to positive infinity. But f of x equals to negative e powered by x plus minus b. If there was a negative behind e powered by x, we reflect it with respect to the x-axis, and our graph goes to negative infinity. Therefore, in that case, domain is again all the real number, but the range, be careful. The range in this case would be from negative infinity to b. Just like this case that we already solved it, from negative infinity to b. What is b? 1. That's why we just said that from negative infinity to 1. All right, so based on these 2 notes, I hope that you note down them in your notebook and take care of them during the questions. So right now, the next slide, again, we have got 3 different questions. So we need 3 coordinate plane. Okay. All right, so let's just go one by one. The first one is parent function, e powered by x, so the graph easily is something like this. The second one is e powered by negative x. We said that if we have negative in the exponent behind the x, we are just going to reflect it with respect to the y-axis. So in that case, the graph would be something like this. This is what we call reflection with respect to the y-axis. So if the white one is the graph of e powered by x, the red one is the graph of e powered by negative x. And I hope that you can see the differences. E powered by x is a growth exponential function. E powered by negative x is a decay exponential function. You might ask me, what is the reason? Remember, e powered by negative x, it's equal to 1 over e powered by x. So 1 over e. E is bigger than 1. So 1 over 1 divided by something bigger than itself. Of course, it's going to give us something between 0 and 1, which is a decay exponential function. And finally, the last one. So we need to move this function, this graph, which is e powered by negative x, 1 unit up. So that's 0, 1. If we move it 1 unit up, here it's going to become 2. All right. And first of all, let's just draw this line, which is y equals to 1. Whatever this is, this number, try to make a line equals to that number, and then the graph would be either above it or below it. If there was positive e, يعني the sign of e was positive, it's going to become like be above it. But if there was negative behind it, it's going to be below it. Okay, so here the graph would go something like this, and here it's going to be 2, and this is the graph of e powered by negative x plus 1. So here domain is all the real numbers, and the range is based on that note that previously I just gave it to you. It's from since behind e powered by negative x is positive, or we can say that since the sign of e is positive, so it goes to positive infinity. From where? From that b. Our b is 1. That's all about graphing by using transformation, and I believe it's going to make the graphing easier. What else do we have? I guess we have got nothing to solve, so I will just solve my own questions. Let me just give you some more questions in order to be better. So we have got 5 minutes. All right. Let's say, what if we have f of x equals to e powered by x, f of x equals to e powered by x minus 4, f of x equals to e powered by x plus 6, and f of x equals to negative e powered by x plus, let's say, e powered by x minus 1 plus 5. All right. So we need 5 coordinate plane. Okay, let's just draw each one of them perfectly. All right, the first one is easy. Graph of e powered by x, which is the parent function. 1, 2, 3, 4. 4 actually, we need 4 coordinate plane, but I just draw 5. I might add another function. So e powered by x minus 4. The negative 4 is a different term. It's not in the exponent. Therefore, we need to shift vertically. All right? Since it's negative, we need to go down. So we need to transform this one 4 units down. All right? First of all, I said draw the line of that line. That's a number. So here, let's say it's y equals to negative 4. All right? So here it's going to be negative 3. And then the graph would be something like this. From 1, we transform the parent function, that is 1 unit, plus these 3 units, so it's going to become 4 units. We just shifted down for 4 units. And of course, the range here, the range would be from negative 4 to positive infinity. Why? Because since the sign of e is positive, so it goes to positive infinity. From where? From that b. Our b is negative 4. And then we have got f of x equals to e powered by x plus 6. So as you can see, plus 6 is in the exponent. So we need to go, shift horizontally. If it is positive, we need to go to left. So imagine here is negative 6. And here is 1. So our graph would be something like this. Yes, we just shifted 6 units to left. Perfect. Remember that test that I already told you. For example, here e powered by 0. Always replace 0. E powered by 0, it's equal to 1. 1 minus 4, negative 3. So our graph should go through negative 3. And for here as well, e powered by 0. Or let's say that number here, negative 6. So negative 6 plus 6 is equal to 0. E powered by 0, 1. As you can see, it goes through negative 6 and 1. How about the last one? The last one is very important. So everything is over here. We have reflection, we have horizontal transformation, and we have got vertical transformation. As a suggestion, go in this order. H, RV. Horizontal first, then reflected, then go vertically. So the horizontal one is x minus 1. We need to go 1 unit to right. Why? Because it's negative. So imagine it's here. Let me just draw this one a little bit bigger. Okay, this is our function, our coordinate plane. Let's imagine the parent function is something over there. So if you move it 1 unit to right, so imagine here is 1. So the function would be something like this. The function would be something like this. In that case, how about the reflection? We need to reflect it as well. This is going to be the reflection. Okay, so here is -1. And then we need to transform it 5 units up. So here is 1 unit. 1, 2, 3, 4, and let's say y equals 2. Do you remember that I said, please draw this line, which is y equals to 5. So here is y equals to 5. So y equals to 5. And the graph, we need to transform that graph. Be careful, not the parent function. So right now we are just going to come here. Okay, so the graph would be something like this. That is the graph of negative e powered by x minus 1 plus 5. So again, I'm going to describe what we have done. First of all, we transformed the parent function 1 unit to right. As you can see, this one. And then we reflect it. Here is the reflection. Then we transform it 5 units up. And as you can see, here is it. So if you just put 0, e powered by 0 minus 1, or 1, let's say 1, sorry, not 0, because we have this point, which is 1 and 4. Remember, here is 4, and here is 5. So 1 minus 1, 0. Negative e powered by 0, it's equal to -1 plus 5, it's equal to 4. And as you can see, our graph goes through 1 and 4. And that's actually the end of this section, this transformation. And I hope that you got actually whatever has been explained in this video. Remember, we study like how to graph natural exponential function by using table value method and transformation, of course. So I hope that you got benefit from this lesson. Of course, they interrupt me a lot, so my apology in case if I did like a lot of interruption. So I will see you in another video. Take care of yourself.